Okay, in this video, I'm going to show you guys how to parametrize a line segment. So let's just do this example, going from 1, 2 to 5, 4. First of all, it's always helpful to see a picture, so I will give you guys a picture. So let's say right here we have 1, and this is 2. So this is our starting point. And let's say this right here is my 5, and this right here is my 4. So this is my second point. And we are going to going from here to here. So let me draw some arrows right here for you guys. Now, this right here, just like the good old days, we can find the equation of a line. So y is equal to mx plus b, right? Let's make that happen. So to do that, of course, we are going to do the following. We need a slope, namely m, which is y2 minus y1, so it's 4 minus 2 over x2 minus x1. So we have 5 minus 1. Work this out, we get 1/2. And now you can use that formula, y minus y1 equals m times x minus x1. And perhaps we can pick this to be our x1, y1. So we get y minus 2 equals m is 1/2. And we have x minus x1, which is 1. Seriously, it's just like good old days, right? Very nice, huh? And I will isolate the y. So we get y is equal to 1/2 times x. And we are going to add a 2 on both sides. Well, 1/2 times -1 is -1/2 plus 2, which is the same as saying plus 4 over 2. So -1/2 plus 4 over 2, we get positive 3 over 2. Very good. Just like the good old days, right? But now, we are going to see how to make the movement going from here to here. So we have to come up with parametric equations. And that's what it means to have parametrization of the line segment, right? In fact, we have so many ways to do it. I will show you a few of them. So here is the first way, perhaps the easiest way, right? The easiest way is the following. You take x to be t. Whenever you have y is equal to a function of x, you can always take x to be t and y to be 1/2, but you don't put down x right here anymore. You put down t, and then you put down plus 3/2. Why? Because we know x is the same as t, so you are saying y is equal to 1/2 x plus 3 over 2, which is the same as that, right? Now, whenever we have a parametric equation, we should also give the time interval. And you see, x is the same as t. X is going from 1 to 5. Therefore, the time goes from 1 to 5. So, just like this. This is the easiest way to do it. Now, let's take a look at the second way to make this happen. Maybe you will think that x is equal to t is too boring. Maybe we can power up. So let's talk about t squared. In that case, this right here is just as easy because we can write this down as y equals 1/2, but you don't put down x, you put down t squared because t squared is the same as x, and then you write down plus 3 over 2. This right here is also just as legitimate, but again, if we want to go from this point to here, we have to give the time interval. T, well, I don't know, x is t squared. X is going from 1 to 5. So when x is 1, you can take the square root on both sides and take the positive version of it, so we get 1. And of course, if you put 5 right here, you take the square root, we get square root of 5. And now that's how we figure out the time interval. T will be going from 1 to square root of 5. So it's going faster, right? Because you will be going from here to here in a shorter amount of time compared to this. So it's better. Maybe it's better. All right, third way. Maybe you think this is too boring. You can just pick whatever you want for x, and then you just put the same thing right here, right? This time, let's do a slightly challenging one. And maybe I don't want to just, figure out the time interval after we have the equation. So maybe we'll do, let's say, I want the time interval to go from 0 to 2. I really want the time begin with 0, and I want to end up with 2. So I only have 2 seconds, for example, whatever units you're using for time. Right, let's say 2 seconds to go from here to here. How can we make that happen? First of all, put down x, and of course, put down y. Now, when t is 0, we have to make sure x is at 1. So if you just put down t, this is not good enough because this is 0. It's okay, we can just add a 1 to it. So when t is 0, x will be 1, right? But when t is 2, if you put 2 right here, 2 plus 1 is 3. Unfortunately, we don't get 2x equals 5. So how can we make that happen though? It's okay, don't worry, just multiply this by 2. Because if you put 2 right here, 2 times 2 is 4, plus 1 is 5, and we achieved that for the x. And now we will do the same trick. Because we have y, we can just write down 1/2. And the x is this now, so I'll just put this down, which is 2t plus 1. And don't forget, we still have to add the 3 over 2, like this. And that will do it. And of course, you can simplify this a little bit. Multiply this in, this times that is just t, this times that is 1/2, plus 3/2, we get 2. So we take this for x, and we take this for y, and the time interval is just going from 0 to 2. And let's double check. If t is equal to 0, y starts at 2. And if t is at 2, put 2 right here, 2 plus 2 is 4. And this is a straight line movement, just like this. And of course, if you want to make sure it's a straight line movement, you can just put t is equal to 1, and you get, in this case, will be 3, 3, and you will actually get 3, 3 right here. But I will leave that to you guys to verify. And these are my answers. You guys can leave a comment down below and let me know what other parametrization that you would like to parametrize this line segment. Or maybe you can comment down below and let me know which of these right here that you like the most, right? And for my students who are watching this, you can just present one of this to be on the homework or on the test. But anyway, that's it.